Hey, Utens. Welcome to exercise 17.6, where we take a look at the remainder and factor theorems. Now, on the front page, we do have both theorems in detail, and it actually takes a little more than just writing to maybe fully understand what's going on. So I feel like rather than learning the why first, so this is why the remainder and factor theorem works and the proof. Let's just learn how, and then we'll go backwards in class and we'll learn about the why together on the board. So if we take a look at example one, the remainder theorem, we can actually find the remainder of a polynomial when it's been divided without actually having to do the long division. Now, this process is actually a shortcut, and it instantly tells us if, for example, here, x cubed take away 7x squared, take away 2x plus 4 divided by x take away 3 has any remainders. And what we do is we substitute in the opposite of the sign. And again, I'll explain the proof in class, but let's just learn the how to do the shortcut first, and then we'll learn about why the shortcut works. So without actually having to divide, find the remainder when x cubed take away 7x squared, take away 2x plus 4 is divided by x take away 3. Well, the remainder is going to be equal to, well, the opposite of negative 3 is positive 3. The 3 squared take away 7 squared take 2 times 3 plus 4. Okay, so if we just simply solve this by substituting in the opposite of negative 3 or the inverse, we get ourselves the remainder. So 3 times 3 is 9. Oh, wait, this is cubed, isn't it? So let's erase that. We get ourselves 27 instead. This part here, negative 7 times 9, because 3 times 3 is 9. Negative 7 times 9 gets us negative 63. Take away 6 plus 4. This will give us an answer of, let's see, what's that, negative 90. No, it's not. Negative 36 take 6 is negative 42 plus 4 gets us negative 38. All right, and then we have our remainder without actually having to do long division, just by substituting in the opposite of the numerical value that's in the divisor. And there's a long, complicated proof, but I don't think it's all that complicated once we understand the substitution process that we just did. In part B, it's much the same. Our remainder, where we don't need to do any long division, is going to be the opposite of positive 6 is negative 6. So we'll have negative 6 cubed. Take away 7 times negative 6 squared. Take 2 times negative 6 plus 4. So what is negative 6 cubed? This will get us negative 216. Okay, because you'll get 36 times negative 6, which gets us negative 216. So negative 6 times 6 is positive 36. So negative 7 times positive 36 gets us negative 252. Let's just put these in so we know. Negative 2 times Negative 6 gets us positive 12, and then we plus 4 here, which gets us, let's see, negative 216 take 252 is negative 460 plus 12 plus 4 equals negative 452. Now, what do these answers mean? If the remainder equals 0, then the divisor is a factor of the dividend. So again, this is our dividend. Okay, and then these are our divisors. Okay, the x take 3 and the x plus 6. And why is this important? Because when you do sketching of polynomials, like cubics, sorry, when you do sketching of cubics, you can shortcut to see which values will leave you a remainder of 0, which means it's a factor of a cubic, which means you can break it down into a quadratic to factorize the other two x-intercepts, because with a cubic, often what you get are 3 x-intercepts. And so right here in example 1a and 1b, x take away 3 and x plus 6 are not factors of the dividend x cubed take away 7x squared, take 2x plus 4. And it's a really handy shortcut because it just saves us a lot of time when we get to sketching of cubics. And this is just one of the repertoires you need to add to your bag of skills later on, especially in methods. Okay, so I'll just write down below, therefore x take 3 is not a factor. And then down here, therefore, x plus 6 is also not a factor. Right. And so this takes us to the factor theorem. So let's assume we try, like, this process takes a little bit of trial and error. I think in year 12, they won't ever get you to trial and error more than plus minus 5. What does that mean? It'll make sense next year when you start sketching. But let's assume that we do get a remainder of 0. That means, bang, we've guessed that a factor of the cubic equation. And so we can move on to the factor theorem. So let's assume one of these got a 0. And so the factor theorem is also useful once we get a remainder of 0 in finding missing values in cubic polynomial equations. And so often what you do is actually not do this example, but to like actually factorize the quadratic once you get it, to find the other two x-intercept values. But again, that probably doesn't make any sense right now. We'll cover that in class together, so we can do a Q&A as we go. All right, but the factor theorem here in this exercise wants you to find missing coefficients within, I guess, the cubic expression. Okay, so here we've got x cubed plus kx squared plus x take away 2. Now we have to find the value of k when we know that x take away 2 is a factor, meaning we've done the remainder theorem, okay, and it's ended up with 0. We know x take away 2 is a factor, but we don't know what the value of k is. And here's how we go about it. Basically, what we need to do is we need to use our linear equation skills, and we need to let's rewrite the equation. We need to take the -2 and flip it to a positive. Why? Again, it comes back down to the proof, sort of similar to the null factor law, sort of not. Okay, it's not, but you know, for now, let's think of it as a null factor law, similar to that sort of concept. And we replace all the x's with 2. So this becomes 2 cubed. The k stays. What's this? Right, so we've replaced all the x's with 2. And so to actually solve this, what we need to do is we need to make this equal to 0. So we can get k by itself on one side. And before we do that, though, we need to simplify everything down. So 2 cubed is 8. Plus, what's this? 2 times 2 is 4, 4k. And they cancel out. And this equals 0. We got to move the 8 to the other side, so we're left with 4k equals -8. And to get k by itself, we need to divide both sides by 4, which means we're left with -8 divided by 4, which gets us -2. So therefore, the k value is -2 in this instance. All right, that's all for exercise 17.6. Again, there's a little more than meets the eye, especially with the proof, which we'll cover, and hopefully we get the big picture once we move into calculus next year. But we'll see some proofs in class 2. Okay, thanks everyone.